All right, so to finish number 91, now we need to do our calculation, which is just to calculate the 99% confidence interval. So to show the 99% confidence interval, I'm just going to do that all in our calculator. So remember, to calculate that, you go to Stat, Test, and this is a Z-score confidence interval. So remember, since we have one proportion, that's going to be letter A, one proportion, Z interval. It's going to ask for my sample data. Well, there's 46 out of 120 of them that this applied to. And I want to calculate the 99% confidence interval. So it's going to be 0.99. And when I hit calculate, I get my confidence interval. So it's going to be 0.269 to 0.498. And then we can make a comment about this situation. So this is I am or we are so much percent confident. So I'll just say we are 99% confident. And it's about the population. Remember, all of our tests in Unit 5 relate back to the population. So we use sample data to make a prediction or estimate or a claim about the population. So we are 99% confident that the population proportion of U.S. residents, so now I'm just copying down the context right here, that have bought prescription drugs in a foreign country is between the lower bound of your confidence interval, so 0.269, and the upper bound of your confidence interval, so 0.498. Okay, so now let's do the same thing, but now with a hypothesis test, but we'll still deal with proportions. Also keep in mind, guys, that your final is all multiple choice, so you won't be writing these sentences on your own, but they may be part of A, B, C, D, so you have to know which one to pick, okay? So number 92, a department store at a large mall claims that over 60% of the mall's visitors shop at that store. A consumer group doubts this claim. So the consumer group took a poll from a random sample of mall visitors and found that 49 out of 100 people that they surveyed had shopped. Is there convincing evidence to support the consumer group's claim? So the consumer group's claim is that they doubt that. So my hypotheses, the null hypothesis and my alternative hypothesis. This is a proportion about, or I'm sorry, this is a question about proportions, right? Percents are proportions. Remember the null hypothesis, you have to assume that it's going to equal exactly 60%, okay? The department store claims that it's over 60%, but a consumer group doubts this claim. So if they doubt this claim, they're thinking that the proportion is going to be less than 0.6. Okay, so we're trying to support the consumer group's claims, which doubts the claim that it's over 60%. So it has to be less than 0.6 for the alternative. So let's check the conditions. When you check these conditions, since it's still a proportion, we are still checking them the exact same way I did for the confidence interval. So I would say that we have a random sample, and let me actually make sure that it says that it does, that we have a random sample of mall visitors. So we did meet the random requirement. And then now we need to check that n times p and n times 1 minus p is greater than or equal to 10. In this case, guys, do not use the sample data. Do not use 49 out of 100 like we did up here. The only reason why we did that in a confidence interval is because we didn't know the true population proportion. In this case, we know the claimed population proportion. That's 0.6. So for n times p, we would do the sample size, which is 100, times the population proportion, not 49 out of 100. Okay, so that's how I get 60, which is greater than or equal to 10. And n times 1 minus p would be 100 times 1 minus 0.6, which is going to be 40. And that's also greater than or equal to 10. Just be careful about that. Don't fall into that trap and use p hat. If you know the population proportion, we're going to use the population proportion. But if you don't, that's where we use p hat to help us. So we have and approximately normal distribution. Okay, our calculations for a hypothesis test, in this case, since it's about proportions, it's going to give us our z-score and our p-value. Okay, remember proportions are z-scores, so I'll write that again, even though I put that up in 91. So proportions equals z. So let's see, in my calculator, I'm going to go to stat test again. So stat test, but this time I want one proportion z test, not z int. So that's going to be number 5. The p sub 0 is my hypothesized value, which is 0.6. My sample data was 49 out of 100, and my alternative hypothesis doubts the claim that it's over 0.6, so it has to be less than 0.6. And I'm just going to hit draw. Doesn't matter if you hit draw or calculate. Draw will show the curve, and it'll show us our values below here. So I get a z-score of negative 2.245. 2.245 and a p-value of 0.012. And now I can make my comment. My comment is always going to be 2 sentences. We're first going to compare that p-value to alpha. So since the p-value is, remember that alpha in our case is always equal to 0.05. We will always do these tests at the 5% significance level. It's not the only way to do it, but that's the only way that we do it in our class. So since the p-value is less than or equal to, so I'm just going to say since the p-value is less than or equal to alpha, because 0.012 is definitely less than 0.05. Remember, that is statistically significant. That means it's very unlikely to happen. So we reject the null hypothesis. And what this means, since that's statistically significant, if you're able to reject the null hypothesis, that there is sufficient evidence or convincing evidence, whatever you want to say, to support the consumer group's claims. And all that means is that the proportion, so it's the proportion of mall visitors is less than 60% that shop at that store. And remember, you're not writing these sentences. The reason why I showed you a little bit more detail is just in case the multiple choice had a little bit more detail, and then you would include that. So just pay attention when you're looking at that. Okay, on page 17, number 93, let's at least write the hypotheses because I can get through that, and then we'll finish this up in the next video. So each person in a random sample of 200 students, and that is nice, say random sample of 200 students, and 100 faculty members at a large university was asked, do you exercise regularly? 104 students and 42 faculty members responded yes. So they want to know, does the data suggest that more students than faculty members exercise regularly? And assume the conditions have been met. So we don't need to check any of that. So the only thing I'm going to get accomplished in this video is writing the hypotheses. So the null hypothesis and the alternative hypothesis. This is still a proportion problem because you're taking a proportion of the students and a proportion of the faculty. So I'm still going to use the population proportion symbol, which is P, but now I'm comparing two groups. Since they talked about students first, I'm going to go ahead and do the proportion of students. And over here, I'll just say S equals students. And remember the null hypothesis, you have to assume there's no difference. So that's going to equal the proportion of faculty. But the alternative, we're trying to gather evidence that more students than faculty. So students are more than the proportion of faculty that exercise regularly. And this will be our 2 proportion example. So we are going to take a look at that and solve this 2 proportion example so you can see how that test plays out.